hyperboloid in 2 sheets. So let's kind of look at the formula to kind of pick out. Again, don't necessarily worry about memorizing this. If you find the traces, it falls out. So for example, the cone, if you find that you get lines for traces, that tells you it's a cone. Cones are the only shape that you can get lines for traces. The other ones will be ellipses, parabolas, hyperbolas. But looking here, all 3 again are squared. Okay, all 3 of them are squared. And 2 are the same sign, one's a different sign, but you have a non-zero constant. Okay, notice this is not 0, so there's going to be a non-zero constant. If you don't have the non-zero constant, then it'll be a cone. Okay, I mean this basically has the same format as a cone, but with a cone it was set equal to 0. If it's not set equal to 0, you're going to get one of these hyperboloids in 2 sheets. But again, don't really get hung up memorizing that. Worry about being able to find traces. So in this case, why don't we deal with the gap here, because that's why it's called a hyperboloid in 2 sheets, because it is separated. If you try to put the origin in, okay, I'm putting the origin, I get 0 equals 1, but that's not true. Okay, so that tells you that there is a gap. The origin, as well as other points and other values, are not on the surface. Okay, and that can happen with these. It happens because you have that non-zero constant, and so when you're squaring things, you get into a situation where, okay, wait a minute, this can't be positive or this can't be negative, and so you end up leaving points out. Okay, so that was the first thing that was kind of different from some of the other ones. We've got this gap between our 2 shapes. If I make x equal to, let's make x equal to 2. Okay, I'm going to plug 2 in for x. So I get minus 4 over 4 minus y squared over 9 plus z squared over 4 equals 1. So this is negative 1, but if I move it to the other side and kind of rearrange things so it's a little more familiar, I get, okay, so this was negative 1, but then I moved it to the other side, but I'm going to try to make that equal to 1, so I'm going to now divide by 2. Okay, this is a hyperbola, and if you drew a graph of this hyperbola, it would be in the, we're finding the trace in the plane x equals 2. Okay, this plane is parallel to the YZ plane. It's not, so I'm labeling Z and Y, but we're really in a plane parallel to the YZ plane. We're in the plane x equals 2. But if I sketched a graph of this hyperbola and understood that it was in the plane x equals 2, then it opens up the z-axis, because z is positive, and the square root of 8 is a little bit less than 3. So there would be the square root of 8. That forms the box, sorry, the z direction. so I get that box in the z direction, it's gonna stop at the square root of 8. The square root of 18 is a little bit bigger than 4. So the square root of 18, there's the other side of the box. And then there are my asymptotes. By the way, I'm gonna draw it bigger over here. So that would be the trace in the plane x equals 2. So picture it's a plane parallel to the xy, so the zy plane. The 8 and the 18 do give me some information about it. You want to make sure you have a 1 here before you start interpreting the denominators. In terms of our graph here, if x equaled 2, it would probably be about here, so we're seeing, there's the hyperbola that we're seeing. Yes, Warren?